This video is the video to go along with the coordinate geometry recap homework, where we're going to go over some key skills from GCSE which you need to know and be comfortable with in order to carry on with the rest of the A level. So make sure you've got your homework in front of you so you're able to take notes whilst you're watching this video. First thing we're going to have a look at is how we can find the midpoint of two coordinates. So I've got the 2 points A, which is -4, 2, and B, which is 5, 3, and I want to work out the coordinates of the point that's in the middle. There are different ways you can do this. The easiest way, that will work all the time, is let's focus on the x coordinates first of all, add them together, and divide it by 2. So -4 plus 5 is 1. 1 divided by 2 is 1/2, or 0.5. Now do exactly the same with the y coordinates. 2 plus -3 is 5. Divided by 2 is 2.5. So the midpoint of A, B is 0.5, 2.5, which if I plotted 0.5, 2.5 on here, hopefully that makes sense visually that that point there is in the middle of A and B. Another little example here. So again, if I want to find the midpoint of -3 minus 1 and 7 minus 5, I'm going to add the x coordinates together and divide it by 2. So -3 plus 7 is 4. 4 divided by 2 is 2. And then do the same thing with the y coordinates. -1 plus -5 divided by 2. So we get -1 plus -5 is -6. -6 divided by 2 is -3. So the point 2 minus 3 is the midpoint of those two coordinates. Next, we're going to look at the distance between two coordinates, or sometimes it's called the length of a line segment. So the distance between these 2 points, the length of the line segment between A and B. You might see this formula written down in some places. I would completely ignore that formula. It makes a very simple concept much more complicated than it needs to be. Because to work out the length of this line, all we actually need to do is a little bit of Pythagoras. Because I'm going to have a right angle triangle. All I need to do is work out what this is, and then I can do Pythagoras. And those are really easy to work out, because if I focus on the x coordinates first of all, the x coordinate here is -2. The x coordinate there is 2. So I've gone from -2 to +2, so I've gone along 4. -2 plus 4 gives me 2. Now if I do a similar thing with the y coordinates, this is 1, this is 4, so I've gone up 3. And now a little bit of Pythagoras then. 4 squared plus the 3 squared, all square rooted, is 5. So the length of that line segment is 5. We don't have any specified units like centimetres or metres or anything like that, so I would just say that it's 5 units for now. So to work out the distance between 2 points, all you need to do, work out the change in the x coordinates, then work out the change in the y coordinates, and do a little bit of Pythagoras. So in this case, the difference between -1 and 4 is 5. The difference between -3 and 7 is 10. And then a little bit of Pythagoras then. 5 squared plus 10 squared, all square rooted, 5 squared is 25, 10 squared is 100, so root 125, which as a simplified surd is 5 root 25. That's it in its exact form. That's the best way to leave your answer in A-level maths. We like things in exact form. If you had to give it as a decimal to one decimal place, though, we could say it was 11.2 units, whatever the units were. But exact form is better for A-level maths. Next, let's talk about how we can find the gradient of a line. I've got two lines here, a blue line and a green line. How can I find the gradient or the steepness? The gradient is always the change in the y divided by the change in the x. Now, if I'm given the equation, if I'm given the line on a graph here, I can choose any 2 points. So for example, I could choose this point here and this point here, and the change in the x coordinates and the change in the y coordinates I can read off. I can see the change in the x here is 3. The change in the y here, I've gone up 6. So 6 divided by 3 is 2. So the gradient of the blue line there is 2. Now, I deliberately chose 2 points that were quite far away there. The easier ones to choose, I think, are usually a point on the y-intercept, if you can read it off easily, and a point here. Change in x is 1, change in y is 2, so 2 divided by 1 is 2. It doesn't matter, you can do it either way. For the green line, this point here, and I'm finding another point that I can read off easily. I can't read these off very nicely, they're not on the grid. This one here I can. So when I go across, the change in the x here is 3. The change in the y is -1. It's gone down 1 square. So therefore, the gradient of the green line, the change in the y was -1. The change in the x is 3. So the gradient of the green line is -1/3. For another example, we're told to find the gradient of the line passing through the points -5, 2 and -1, -1. So the change in the y divided by the change in the x. Let's look at the y coordinates first of all. So I've got a 2 and a -1. So the change there is 2 minus -1. Now let's do the change in the x coordinates. So I'm going to do -5, take away -1. The two negatives there will become a positive, so 2 plus 1 is 3. Again, these negatives here will become a positive, so will become +1. So -5 plus 1 is -4, and 3 divided by -4, I would say that that is equal to -3/4. So the gradient there is -3/4. And then finally for this video, we're going to talk about the equation of a line. Now generally most of the time, we will have the equation of the line as being y equals mx plus c, where m is the gradient, c is the intercept. So this blue line here, I can see that the y-intercept here is -2. So that is the c value. And the m value, we can work that out like we did on the previous slide. Oops. By finding how much we're going up by when we go across, the change in the y divided by the change in the x. In this case, I can see that the change in the y is 3 when the change in the x is 1. So the gradient is 3. So y equals 3x minus 2 is the equation of that line. There will be some situations, though, where we end up getting quite awkward numbers for the gradient or the y-intercept. And in those cases, it can be useful to reorganize and tidy up the equation of the straight line so it looks like that, in the form ax plus by plus c equals 0. And we're going to see that with this next example. It says to find the equation of the line passing through the points minus 2, 3 and 2, 1. I'm going to start by working out the gradient of this line. So I'm going to do the change in the y coordinates. So 3 minus 1 divided by the change in the x coordinates. So minus 2, minus 2. So 3 minus 1 is 2. Minus 2 is minus 4. And the 2 divided by minus 4 is the same thing as minus 1/2. You might be tempted to write 0.5 there. Don't. Keep it as fractions for all your work on coordinate geometry, especially with the gradient. So I know my gradient is minus 1/2. So I can now write down start to write down the equation of this line. I can say y equals mx plus c, and I've just worked out that the m is minus 1/2, so I can put that in. But I don't know the y-intercept yet. I still need to work that out. But that's fine, because I do know 2 points that the line goes through. I know it goes through the point minus 2, 3, and it also goes through the point 2, 1. So I could substitute either of those into this equation to help me to work out what c is. It doesn't matter which you do, but I'm going to choose to do this one just because I don't have to deal with the negative that way. Just makes my life a little bit easier. So I can see that x is 2 when y is 1. So if I put those in the right places, so 1 equals minus 1/2 times 2, or 1/2 of 2 is 1 times with the minus, and minus 1 plus the c. I'm then going to add the 1 to both sides to get c. I've now managed to work out what my y-intercept is. So I can now write down the full equation of this line. Remember, the gradient was minus 1/2, and the y-intercept I've just worked out is 2. But this equation here is a bit messy, that minus 1/2 x plus 2. I don't like the minus 1/2. I don't like this fraction or the fact it's a negative. So what I'm going to do is I'm going to multiply both sides by 2 to get rid of this fraction. So timesing the left-hand side by 2, I'll get 2y. Timesing this by 2, I'll just get minus x. And timesing the 2 by 2, I'll get 4. And now what I'm also going to do is I'm going to add the x to both sides, so it becomes a positive. And I'm also going to subtract the 4 from both sides so that it equals 0. And now this is in that form that sometimes the questions will ask you to do. Personally, I prefer the y equals mx plus c form, because that's nice, because you can see what the y-intercept is, you can see what the gradient is, so that allows you to picture what the graph would look like easily. I can see my y-intercept is 2, the gradient is minus 1/2, so it goes along 2, down 1, along 2, down 1. So that allows me to draw this graph in really easily. So this form is good for visualizing, but it's a bit messy in terms of fractions and negatives. So that's why sometimes you have to do this rearranging in the form ax plus by plus c equals 0.